We begin a question-answer session on nuclear and particle physics, and let us begin this series with the first lecture. The first question coming up. In a nuclear reactor, plutonium is used as a fuel that undergoes the following nuclear fission. Pu for plutonium, N for neutron, Ba for barium, and Sr is strontium. Binding energy per nucleon of plutonium, barium and strontium are 7.6, 8.2, 8.6 MeV respectively. The number of such fissions per second in a 100 megawatt reactor is, and the options are option A, option B, option C, and option D. The answer: nuclear reactor operates on the fission reaction. In this reaction, the participants are plutonium of mass number 239 and it has atomic number 94. It fissions into barium that has atomic number 56 and mass number 146, and into strontium that has atomic number 38 and mass number 91. The binding energy per nucleon is, for plutonium it is 7.6 MeV, for barium it is 8.2 MeV, and for strontium it is 8.6 MeV. So binding energy is, for plutonium it is 239 nucleons into 7.6 MeV. For barium it is 146 nucleons into 8.2 MeV, plus for strontium it is 91 nucleons into 8.6 MeV. Calculation gives this one to be 1816.4 MeV and this one to be 1979.8 MeV. Difference in binding energy is 163.4 MeV. That turns out to be, let us convert into joules. So it is 2.6 into 10 to the power minus 11 joules, and this is the energy released in one fission. Nuclear reactor has power, that is wattage, to be 100 megawatt, which is 10 to the power 8 joule per second. Now number of fissions per second equal to total energy per second by energy per fission. Substitute the values to get 3.9 into 10 to the power 18 fissions per second. So this is the correct answer. It is option A. Next question. A proton is accelerated to energy E and collides with oxygen-16 nucleus. The value of E to reach surface of oxygen-16 nucleus is, the options are A, B, C, and D. Let us come to the answer now. Proton has charge modulus E equal to 1.6 into 10 to the power minus 19 Coulomb. Oxygen-16 has 8 protons, 8 neutrons, and so charge is 8 times mod of E. The proton will be repelled by the 8 protons of oxygen nucleus, and this repulsion can be regarded as a Coulomb repulsive barrier of value. This is the Coulomb potential barrier, where R is R0 a to the power 1/3. Again, R0 is 1.2 Fermi. So this is the radius of oxygen nucleus. Substitute into it the values to get 6.09 into 10 to the power minus 13 joules. Convert this into electron volt by dividing by 1.6 into 10 to the power minus 19. This leads to 3.8 MeV. So the answer is this one, which is option D.